Whenever you want to find like a range of numbers, so whenever you want to find like when x is equal to, like in this case, 2, 3, and 4, you want to use CDF. So the cool thing about CDF, it actually lets you pick what the lowest number is and what the highest number is. So in this case scenario, what was the lowest number that we said x could be equal to?
2.
2, so you put 2 right here. What did we say the highest number that x could be equal to was?
4.
Yeah. So you go 2 to 4, and if you actually go to the drawing, you can see that only 2, 3, and 4 is highlighted. So the probability from 2 to 4 is equal to 0.542. All right, so that should help you out with the second part of the homework that I gave you yesterday. So anytime it says at least means that's the lowest number, but it could be anything higher than that value. So for this one, it was 2, 3, and 4. Okay. And that's your final answer. So let's go back for that. You can see how I enter the number, but it should be pretty straightforward. All right, so if you look at B, I put probability that x is equal to 2, 3, or 4 is equal to 0.542. All right, so let's do C. So if you look at C, it says fewer than 2 of them respond yes. So if I want fewer than 2 of them respond yes, so fewer than 2 mean it has to be below 2. So the only two numbers that are below 2, in this case, will be 0 and 1. There we go. So 0 and 1. So when I go back to class calc, what I have to tell class calc that I want it to be from 0 all the way through 1. So let's go back to class calc. All right, so now if I go back to class calc, I'm going to erase this. I'm going to erase this. So what I want to tell class calc that I want it to start off at 0, and I want it to go all the way up to 1. So if you look at the drawing now, you can see only 0 and 1 is selected because those are the two probability that it's going to get. So from 0 to 1, the probability of that occurring is 0.458. All right, and that's it for part C. Any question in regard to part C?
No.
All right, so let's go ahead and let's do the next problem. All right, so for this next problem, it says a survey indicates that 21% of men in the US consider fishing their favorite leisure time activity. You randomly select 5 men and ask them if fishing is their favorite leisure time activity. So find the probability of exactly 3 of them responding yes and at most 2 of them responding yes. All right, so before we get to A and B, what we're gonna do, we're gonna say what's our N and what's our P. So for this one, what would be our N value?
Five.
Oh, there we go, 5. And then if you look at P, P will be the probability that their favorite leisure time activity is fishing, and that's 21%. So you go 0.21. All right. So we got N is equal to 5 because they told us they selected 5 men, and we got P is equal to 0.21 because that's the probability that their favorite leisure time activity is fishing. So let's do part A. So for part A, it says exactly 3 of them respond yes. So if you look at it, it says exactly 3 of them, so we want X to be 3. So if you look at this one, since we only want to find one certain value, that means we're going to use PDF, because you always use PDF when you want to find exactly one probability. So let's go over to class calc. All right, so let's do this. All right, so remember, to go to binomial, you go to stats, you go to distribution, and you go to binomial distribution. So right here for n is gonna be 5. If you go over here, my p is gonna be 0.21. All right, so we're gonna do PDF right now because we wanna find when x is exactly 3. So you put 3 right here. All right, and you get 0.05779. So we'll say 0.0578. All right, and that's it for part A. Any question for part A? All right, let's do part B. All right, so part B says at most 2 of them respond yes. So if you look right here, it's not saying at least, it's saying at most. So at most means that's the max, but it could be smaller. So anytime you see the word at most is telling you that's the max, but it could be smaller than that value. Other thing, like if you want the mathematical inequality, it should be less than or equal to. Okay, we're saying it could equal to this number, but it could also be smaller than this number. So if you look at this one, it says at most 2 of them respond yes. So that means we want to find the probability that x is equal to 0, 1, and 2. So we want to find the probability that x is either equal to 0, 1, or 2. Any questions so far on how I found those x values? All right, so let's go back to class calc. Let's do this. All right, so now instead of doing PDF, we're gonna do CDF. Because if you look at it, since I have a range of number, that's when you want to use CDF. So for CDF, we're gonna say the lowest it could be is 0. The highest it could be, well, we said it was 2. So if you look at that one, we get the probability is 0.9341. And that's it for this binomial distribution. All right. So that's it for this problem. So let's go on to the next one. Let's go here. Sure. So if you want to see how I enter the number or put the solution, that's how I did it. So I said probably that x is equal to 0, 1, or 2 is equal to 0.9341. All right, so let's go on to the next problem. All right, so for this one, says the result of a recent survey indicate that when grilling, 59% of households in the US has a gas grill. If you randomly select 100 households, what are the probability that at least 65 households use a gas grill? All right, so for this one, what's my n?
100.
Yeah, 100. So we put n is equal to 100. All right, so for this one, what's my p? What percent of Americans have a gas grill?
59.
Yeah, so we put 0.59. Wait. All right. So if you look at this problem, we want to find the probability that at least 65 households have the gas grill. So for this one, you really don't want to like write it out. So we're gonna say X is greater than or equal to 65. Because we want to find the probability that X is either greater than or equal to 65. So for this one, you pretty much your X value should start off at 65 and should keep on going and going all the way to 100. So for this one, you really, really don't want to do it by hand. You kind of want to let your calculator do this one. Because if you do it by hand, you're going to have to do roughly like 35 times the formula. So you don't want to do that. So everybody good how we got n is equal to 100, p is equal to 0.59, and x is greater than or equal to 65. All right, so let's go ahead and do this problem. All right, so let's go to stats, let's go to distribution, let's go to binomial distribution. So we'll say n is 100, we'll say p is 0.59. And for this one, you want to use CDF because if you look at it, you don't want one number, you want a range of numbers. So you want to use CDF. So for my lowest, we'll put 65. And if you look for the highest, we'll put 100. All right, so if you look at my calculator, if you look at the distribution, you could kind of see how it got 65 and then everything to 100. All right, so if you look at that probability, we get 0.1313. And that's your final answer for that question. Any question in regard to the last problem? All right, so let's go ahead and do the next problem. Cool. All right, so if you look right here, here goes the answer. So we'll say probability that x is greater than or equal to 65 is 0.1313. So let's go ahead and do the next one. So for this one said the results of a survey indicate that 67% of US adults consider air conditioner a necessity. If you randomly select 100 adults, what are the probability that at most 75 adults consider air conditioning a necessity? Use technology to find the probability. So if you look at this one, first thing you want to see is how many people did they randomly select. So they randomly selected 100 people. So that means, oops. Sure. So that means n is equal to 100 because they tell us they randomly selected 100 people. Next thing you want to do, you want to get probability of p. So you go p is equal to 0.67 because that's how many people consider air conditioner a necessity. Next thing you want to do, you want to get x. So right here it says at most. So remember, whenever it says at most, that means that's the max, but it could be anything lower than 75. So in this case scenario, we'll say 0 all the way up to 75. Because it says at most 75, that means 75 is the highest, and you go all the way down to 0. All right, so technically, we're going to be finding the probability that x is less than or equal to 75. All right. Any questions so far with that? All right, so let's go over onto class calc and let's do this answer. All right. So for class calc, we go here, we go to stats, we'll go to distribution, and we'll go to binomial distribution. So we'll say n is equal to 100. P is equal to 0.67. We'll say CDF. Let's magnify that. So if you look at, you start off at 0, and then you tell it go all the way to 75. So if you look at my drawing right here of the histogram, you can see that 75 is the highest number that I got, and you keep going all the way down. So that probability is 0.9672. So it's telling us the probability that at most 75 people will say that air conditioning is a necessity. It's kind of telling us that if we have 100 people, that the probability that at most 75%, at most 75 of them will say air conditioning is a necessity. It's pretty much telling you that's very likely that we get at most 75. Cool. All right, and that's it for that last problem. Any question for that last problem? Right, so let's go back to the iPad. All right, so what I want you to do, I want you to practice on this next problem. So take a minute and practice on this one. And we'll do a poll right now. So we'll say A, we'll say B, we'll say C, and we'll say D. So let me give myself some answer. So once you get your answer, you see you choose A, B, C, or D. All right, so let's end the poll. Let's share the result. Cool. All right, so if you look at 90% of you chose B. Well, not 90% of you, 90% of the people who participated in the survey chose B. 10% of the people who participated in the survey chose C. So the correct answer should have been B. So let's go ahead and how to do B. So for B, if you look at it, it says N is equal to 250, P is equal to 0.71. And you want to find the probability that at most 178 of them will use more than one topping. So for this one, you say X is less than or equal to 178. So if you look at this one, pretty much at most 178 mean that X is 0 all the way to 178. So we have to go X is 0 all the way to 178. So we go over here to class calc. So if you look at it, you go 250 for N. For my probability, you get 0.71. Oops, I got 2 points. Doesn't really like that. And then we're gonna do from 0 all the way to 178. 178. Wait. And if you look at it, you get 0.552. And that's your final answer for that one. So that's how you should have gotten 0.551 or 0.55. Any question for that last one? All right, let's go on to but let's go on to the next question. So same thing, you're gonna do this next problem. I'm gonna give you some options to choose from. Cool. All right, so I want you to do this next problem. So let me make up some of these solutions. Yeah. All right, so those are your four options. So let's do a poll. That's for launch polling. Here, let's put on some thank you music for you. So let's share the poll. All right, so if you look at it, we have 15% of people who participate chose A. We have 8% of people who participate chose B. We have 15% of people who participate chose C. And lastly, we have 62% of people who participate chose D. So for this one, the correct answer should have been D. So let me show you how do you get D. All right. So for this one, you should have gotten N is equal to 8. You should have gotten that P is equal to 10%. And X, if you look at it, it says at least 4 of them carpool to work. So that means you want 4, 5, 6, 7, 8. Yeah, and you stop at 8. So what you want to do, you want to do that in class calc because you have multiple data sets, so you have a multiple range. So let's do this in class calc. So in class calc, I'm going to go ahead and erase this. So you put 8 and you do 0.10. And then right here for the lower bound, you put 4 because that's the lowest it could possibly be. For the highest value it could possibly be, you put 8. And if you look at that, that's how you get the probability that X is greater than or equal to 4 is equal to 0.005. All right, and that's it for the last problem. Any question for the last problem? All right, so before we move on to the mean and standard deviation for a binomial, I'm going to do one more problem. For that way, I could cover all of my bases. Yeah. Here we'll do this. So say in class. Yeah, that's all you have to do. All right, so let's try this problem. So this says, in this class, my instructor Vallejo asked students to participate in a poll. Only 60% participate. If there are 18 students in class, what is the probability? Yeah, there should be a comma, right? What is the probability that more than 17, well, sorry, more than 12 participate? All right, so if you look right here, n is however many students are in my class, so that's 18. If you look at p is 0.60. And if you look at this one, it says more than 12. So more than 12, you have to choose something more than 12. So the number that are more than 12 will be 13, 14, 15, 16, 17, 18. So kind of notice the difference between more than or at least. More than you want to get it bigger than that value. When it says at least mean that it could equal to that number, but it can also be bigger than that number. Everybody good with that so far? All right.
Yeah.
So let's go ahead and go back to class calc. So if you go to class calc, what we have to do, we go to stats, we go to distribution, we go to binomial distribution, we go n is 18, we go p is 0.60, and then we choose CDF. So for CDF, we pick the lowest number. Lowest number will be 13. Highest number will be 18. So if you look at it, there's a 20% chance that more than 12 students will participate. So, telling me not good. All right. And that's it. So you kind of remember anytime it says more, it had to be, the x had to be bigger than that value. So you just kind of know the difference between more than and at least, because it will drastically change your answer. So let me go back to my notes so that way you can kind of see how I enter it in the notes. Great. All right. So if you kind of notice, this is how I drew it. So kind of notice for the inequality, I just wrote greater than. I didn't put equal because it's not equal to 12. It has to be greater than 12. So the probability that x will be greater than 12 will be 0.2088. All right. Any question in regard to that? All right. So let me go back to the notes. So if you have the notes, where you go, follow back to the notes. All right, so now what we're gonna go ahead and do, we're gonna go over how to find the mean, how to find the standard deviation, and how to find the variance for a data set of binomial distribution. So if you look at it, in order for me to get the mean, so in case you don't recognize these, this is the mean, this is the variance, and this is the standard deviation. So in order for you to find the mean, all you have to do is do n times p. If you do n times p, you'll find the mean. If you want to find the variance, you get n, you multiply by p, and then you multiply it by q. So that will give you variance. If you want to go ahead and find standard deviation, you get n, you multiply by p, you multiply by q, but then you take the square root of that information. So that's how we're going to find the mean, variance, and standard deviation. And just remember, this is for binomial distribution. So if we have a binomial distribution, all you have to do in order to find the mean is get n multiplied by p. To get variance, you get n multiplied by p multiplied by q. And to get standard deviation, you get n multiplied by p multiplied by q, and you take the square root. And in case you forgot how to find q, q is equal to 1 minus p. So, all right. Any question for the formula before we go ahead and start doing some problem? All right, so let's do this one. So for this one said, in Hawthorne, California, about 56% of the day in a year are cloudy. Find the mean, variance, and standard deviation for the number of cloudy days during the month of June. Interpret the result and determine any unusual value. All right. So let's go ahead and do this. So we have the month of June. So for the month of June, how many days does the month of June have? Cool. We'll go with that. Cool. So since the month of June has 30 days, that's our n. All right. What percent of the time in the month of June is it cloudy?
56.
Yeah. 0.56. Cool. So if 56% of the time is cloudy, if I want to find the probability that is not cloudy, that's Q. So that'll be 1 minus 0.56, which is 0.44. So just remember, P the probability is cloudy, Q is the probability is not cloudy. All right, so if you look at it, it says find the mean, find the variance, and find the standard deviation. So let's go ahead and find the mean. So if I want to find mean, is equal to n, which is 30, multiplied by 0.56. So I'm going to do that on my calculator. So you do 30 times 0.56. So 30 times 0.56. And you get 16.8 days. So that's our mean. So pretty much it's telling us 16.8 days out of in June are cloudy. So it's telling us if we have 30 days in June, 16 to 17 of those days should be cloudy day. So now we're gonna go ahead and do is find the variance. So for the variance, you get sigma square of x is equal to 30 times 0.56 times 0.44. So if I get 30 times 0.56 times 0.44, let's see, what do I get? So 30 times 0.56 times 0.44, and you get 7.392. Everybody good on variance? All right, lastly, let's do standard deviation. So for standard deviation, you take the square root of 30 times 0.56 times 0.44, but luckily we already found that to be 7.392. So we just have to take the square root of 7.392. So take square root 7.392, and we get roughly 2.72 days. All right, so that's it. So for the mean should be 16.8 days, a cloudy day, and the standard deviation telling us we're not always gonna get exactly 16.8 days, because the standard deviation is telling us like how far off from the mean we could be. So it's telling us we could be 2.72 days away from the mean. But that's it for that problem. So if you look at the mean and standard deviation, or the mean, variance, and standard deviation, shouldn't be that hard. You just do n times p times q to get the variance, or you do square root of n times p times q to get standard deviation. All right, any question for this last problem? All right, let's go to the next problem. All right, so for this one, said in Long Beach, California, 44% of the days are clear. Find the mean, variance, and standard deviation of the number of clear days during the month of May. All right, so let's focus on May. So for May, how many days does May have? Cool, so we have 31. So we get n is equal to 31. So n is equal to 31. P is equal to 0.44. And Q is equal to 1 minus P, which is 0.56. Any question for N, P, or Q? All right, so let's find the mean. So the mean will be N, which is 31, times P, which is 44. So if we do 31 times 44, or 0.44, you get 13.64 days. So if you look at that one, that's how many days we expect to be clear days. So if we have 31 days in May, in Long Beach, we expect that 13.64 of those days to be clear day. All right, so now let's find the variance. So to find the variance, you get 31, you multiply by 0.44, and then you multiply by 0.56. So let's see what does that give us. So 31 times 0.44 times 0.56. If you look at that, you get 7.6384. All right. Any question on variance? All right, so lastly, we're gonna go ahead and do standard deviation. So for standard deviation, you go 31 times 0.44 times 0.56, which you get the square root of 7.6384. So let's see, what do we get from that? So square root of 7.6384. You get 2.76. And this is in days. So if you look at the standard deviation, it is telling us like not every month of May is always going to be 13.64 days of clear sky, because there are going to be some months of May where you get more clear sky or you get less clear sky, because that's what the standard deviation is telling us. It is telling us from one May to the next May to the other May, like how much deviation should we expect for those days, because we're not always going to get 13.64 days of clear sky. All right, and that's it for the second problem for the mean, variance, and standard deviation. Any question in regard to the mean, variance, or standard deviation? All right, so that's it. All right, cool. So we're done with the lecture now. So I'm going to show you, because remember, for today, you do have your quiz. So I'm going to show you where to go for the quiz. So for the quiz, you go here, Blackboard. Also, for today, if you do want to go to my office hour, you click on this one where it says office hour from 11:30, and you click right here where it says start. I don't know what it will say for you, but you go to the office hour for tomorrow, and I should be there today. So if you do have any question about anything, just pop in and ask questions. The quiz should be what we learned about yesterday. All right, so if you go to the home base, all you have to do is scroll down. So what you want to do, you want to go past exam number 2. So for today's activity, you want to do activity 13. So you do want to do activity 13 right here. So that's today's activity that you should be working on when I put you in the breakout room. For the homework, you do want to go over here, and now you should be able to finish all of the homework. Because yesterday I only went over like if it was exactly, but now that I went over at least, at most, or more than, you should be able to finish your binomial distribution homework. All right, but for today's quiz, here, let me make available to you. All right, cool. So for today's quiz, you want to go right here where it says quiz 11, 12, 13, all the way through 19. So all of your pretty much quizzes are going to be here. We're only going to have 19 quizzes. So you want to go here. So for today, you just want to go right here where it says quiz 11. And for today's quiz should be open at 12 p.m. and it'll be available until pretty much today, all the way to 11:59 p.m. So try to do that anytime between 12 p.m. all the way to 11:59 p.m. And I gave you 40 minutes for the quiz, so you should have more than enough time to do the problem. Because to do the problem should probably take you like 10-15 minutes. And then the rest of the time, just upload the quiz onto Blackboard. Okay. And also, if you want to check your activity to make sure that the activity is right, if you go to content, if you go right here, sorry, if you go right here where it says activity, you could check the solution for that activity, so that way you can make sure that you're doing it correct. So whatever activity you have, if you look, I have until activity 19 solution. So you could just go here and you double check your answer, for that way you can make sure that you're doing the activity correct. All right, so let's see. All right, everybody good on where the activity, the homework, and the quizzes are?
Yes, sir.
All right, cool. All right, so what I'm gonna go ahead and do, I'm gonna start breaking you off into the breakout room. So that way you can start working on today's activity. So do, like when I break you up to the breakout room, do talk to the people there. Don't just stay there and not say anything or not do anything. This is your time to work on it and see if you're understanding the material. So do work on your activity. So that way you can kind of see, and I'll pop in like at least one time through everybody. So if you do have any question, just ask me for that way I can help you out. So this is your time to practice on the material and to make sure that you understand the material. So let me break you up into your breakout room. I'm also gonna stop the recording because essentially, since I'm gonna break you up into the breakout room,